Okay, so try this question. We have another negative result here, so watch out for that. And this time I'm looking for my solutions in radians. Right, pause the video and see how you get on with this one. So my first solution, of course, I'm going to do cos inverse minus root 3 over 2. I'm going to do that on the calculator, and I'm going to do it in degrees first. Okay, I much prefer to work in degrees. So 150 degrees is what I'm getting as my answer. So again, I'm going to use my unit circle to figure out where my second solution is. We're 0 to 360 degrees, 2 pi is 360 degrees, so I'm looking for two solutions here. So, 150 degrees is obviously over here in the second quadrant between 90 and 180. And that makes sense because only sine is positive in that quadrant, which means cos must be negative. And of course it needs to be. So the other quadrant where cos is negative is of course this one here. Okay, so again, we need to analyze our spacing. So if this is 150 degrees, this gap here must be a gap of 30. And therefore this gap here must also be a gap of 30. So I want my angle, remember, all the way to here. So in order to figure out that second solution, I would do 180 degrees plus 30. And I would get, of course, 210. And check both of your solutions then. Cos 150 is, of course, minus root 3 over 2, and cos 210 is, of course, giving you the result minus root 3 over 2. Don't forget, of course, I need my answer in radians, so I'm going to do that conversion now. So I'm going to multiply by pi over 180 here, and multiply this one by pi over 180 as well. And I get 5 pi over 6 for my result for 150 degrees, and 7 pi over 6 for my result of 210 degrees. So there we go, there's our angles now, both in radians. Okay, so let's try this question. Two things to point out before you pause the video and give this one a go, and that is, of course, we have a negative result, watch out for that. And also we have a different range here than we've had in the previous examples. This time I'm asking for all the solutions between 0 and 720 degrees, okay? So key thing with this, anyway, is to get your two solutions, your two main solutions between 0 and 360 degrees first, okay? And then I can show you exactly how we're going to get our multiple solutions. Okay, so pause the video and see how far you can get on this one. So again, our usual, finding our first solution, we will do sine inverse of minus a half. Now we're getting a minus 30. Now minus 30, first of all, isn't in the range we want, of course. And where it is, let's have a look at our unit circle here. That's 0, 90, 180, 270, back around to 360. A negative 30 would be going backwards 30 degrees. Okay, so it's actually in this quadrant here. And so technically that angle from here all the way around to here is, of course, if you add 360 onto it, 330. So that angle there in red in that C quadrant is 330 degrees. Or just looking from the unit circle, we realize going back 30 degrees in the unit circle would be going back into the fourth quadrant, and of course technically then that would be 360 take away 30, which is 330 degrees. Okay, so that's our first solution. Now, we know that sine is negative, so that makes sense that we're in the C quadrant. The other quadrant where sine is going to be negative is, of course, the T quadrant, okay? So again, you're going from your horizontal, and we've got equal spacing going on. So if that's a gap of 30, which we know it is, thanks to the reference angle, the angle that they gave me on the calculator, then this is a gap of 30 as well. So now this time, for that angle, we want to go all the way from here to that line. So that angle there. Obviously to the halfway mark, or the straight angle, is 180, and we know this spacing is 30 degrees, which means your other solution is going to be 180 at 30 degrees, which is 210. Now let's just check those answers. Our two main answers is always what you want to do first, no matter what type of question you're dealing with. Let's just check. So I have sine 330 and I'm getting minus a half. Great, I am. And sine 210 and I'm getting minus a half. Super. Okay, so I have my two main solutions, but of course I want more solutions, okay? So since 720 is double 360, and two solutions are always what you get between the range 0 and 360, I know I'm going to get another two solutions if I'm going all the way up to 720. And so we've talked about how to get multiple solutions already. And if you remember from your sine graph, of course, is like this, and it repeats itself every 360 degrees. That is the shape there that repeats and repeats and repeats and so on, okay? So if it repeats every 360 degrees, then all I need to do is add on 360 degrees to 330, which is 690, and add on 360 degrees to 210. And there we go. We have two more angles, all of those in the range 0 to 720 degrees. We're getting four solutions now that will give minus a half. And so to recap, you'll always get your two main solutions first. Always, always, always. No matter what the question asks you, you'll always get your two main solutions. And then, if you need multiple, take those two main solutions and add on 360 degrees. Because with the sine graph, it repeats every 360 degrees. Okay, let's try this example. Tan x is equal to minus root 3. This time again, we've got a range 0 to 720 degrees. Watch out for that. We've got a negative. Watch out for that. And one little thing I want to highlight here. Obviously, we've got our range more than our usual 360 degrees. So again, you're still going to get your two main solutions first. However, if you remember from your tan graphs, and there's a video on the trig graphs if you want to go into it in more detail. The tan is the only one that has its shape repeating every 180 degrees instead of 360. So for tan, if you want multiple solutions, you'll be adding on 180 instead of 360 degrees. And the reason, of course, is that the tan curve repeats itself every 180 degrees. And again, go back to that video on the tan graph so you can actually see that visually for yourself to remind yourself of that fact. Okay, so first things first, you're going to get your two main solutions as always, and then you can look for multiple solutions, okay? So pause the video and see how far you can get on this one yourself. So first solution, of course, we are going to do tan inverse of minus root 3. And we're getting minus 60, so another minus. Okay, so we dealt with that in the last example, so let's have a look for ourselves on the unit circle. So if it's a minus result, we're going backwards into the C quadrant. That makes sense because only the cos is positive between 270 and 360, so tan is negative, and of course it is. Minus 60 we can't use, we need the range between 0 and 720. So what we'll do, of course, is add 360 onto that straight away. And of course, we're getting 300. So check that for yourself. tan of 300 is minus root 3. Okay, good. So we're on the right track. So there's our first of our main solutions. Now, our second solution is going to be where tan is negative again, and tan is going to be negative again in the sine. Again, we're analysing our spacing. If that's 60 degrees from there, that's 60 degrees there. So we want, of course, the angle from here to that line. And of course, if that gap is 60, and of course our straight angle is 180, then we know that 180 minus 60 is the other result. So there we go, 120 degrees. My two main solutions, let's check that for myself. Tan of 120 minus root 3. Perfect. Okay. So now we want multiple solutions, so we have to consider how often the tan graph repeats itself. And given the tan curve, it's the only one that repeats itself every 180 degrees. In order for me now to get multiple solutions, I'll take my two main solutions and add on 180 degrees. Okay, so now with this, we're actually getting the one we had at the start. So what we'll do is just consider now, go again just to see. So let me take 480 and add on 180 just to keep going, more rotations. And I'm getting 660, so that's going to be a solution. It's still within my range, you see. And then the next one then, what I would do would be to take 660 and add on 180 to get another solution. And I'm getting 840. That's outside the range, so I can stop. So there's my four solutions inside the range, 0 to 720. Okay, so let's try this example. This is another different type of example in the case that we have it in terms of theta. That doesn't matter, it could be in terms of x, but we have a 2 theta, could be a 2x, but just we have theta this time representing our angle. This is a double angle, and I want to show you what you have to be very careful of with double angles or triple angles you might have as well, okay? Key thing with this is we need to treat it just as a sine of something, okay? So just consider this box around it, okay? I don't want you separating that 2 from that theta until the very, 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 very end, because you're solving for theta ultimately. But what we need to do though is just consider this as sine of something, that's an angle. Think of it as a, put it in the box there because we're going to solve for that box, that angle. Do all our angle work, and it's not until the very, very end where we'll do our little manipulation to get rid of the 2 to get the theta. Okay, so that's what's key here. Okay, so let's find our two main solutions in our usual way. So keep that together. That's the angle I'm looking for. And of course, sine inverse root 3 over 2 works out to be 60 degrees. Okay, so draw your unit circle. That's where it is in the first quadrant. A gap of 60 degrees this way, of course. And where sine is also positive is going to be in this quadrant, and that's going to be a gap of 60 degrees as well. So my other solution for 2 theta, keep it together, is going to be 180 minus 60, which is 120. Okay, so let's just double check our angle work is okay. So in other words, sine of that angle 60 is root 3 over 2, and sine of that angle 120 is root 3 over 2. Okay, so my angle work is correct. Now, when we are solving for a double angle, initially, with regards to the range, we are going to be able to go from 0 all the way up to 720 because you're going to double everything. Do you see that? The double angle can go up to 720 to give the single angle 360. Okay, so in other words, since I'm solving the double angle for the angle part, It is a double angle. I'm going to get all my angles up to 720. Okay, then when I'm just solving for theta, the theta will land in the range 0 to 360 degrees, which is what I've been asked for. So in terms of my angle, and it's a double angle, I'm going to go all the way up to 720 degrees with my solutions, okay? Which means I can go again to find multiple solutions. The sine curve repeats itself every 360 degrees, so I'm going to take my solution 60 and I'm going to add on 360 degrees. And I get 420, and I'm going to take my second main solution, 120, and I'm going to add on 360, and I'm getting 480. Okay, if I add on 360 again now to 420, you'll get 780, so you're gone beyond what you need to go. So I've gone all the way up as far as I can go with my double angle, which is 720 degrees. And again, you can just check your angle work. Is sine of 420 root 3 over 2? It is. And is sine of 480 root 3 over 2? It is. Okay, so my angle work is good. So that's so key. Get your angle work. Keep it boxed. You've got to keep it together. Do all the angle work. Now I'm finally at my last step. Now I'll solve for the theta. So given that 2 theta is equal to 60 degrees, or 120 degrees, or 420 degrees, or 480 degrees, theta then, which is what they've actually asked me to solve for, will be equal to, well, since 2 theta is equal to all of these, to get theta on its own, I'm now going to divide everything by 2. So I'm left with 30 degrees, or 60 degrees, or 210 degrees, or 240 degrees. And that is my final set of answers. Okay, so this is our final example. And here what I'm asking you to do is find all the solutions, or you may be asked to find the general solution for this trig equation. Okay, so what we need to do for us for all the solutions is we need to write our results and give it so that we include all rotations and what to do to find all possible solutions. So I'll show you how we'll do that at the end. What we always do anyway, of course, is find our 2 main solutions. We have a triple angle here, so again, just like in the previous angle, we're going to have to just keep that together. We'll get rid of the 3 at the very, 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 very end, okay? So what we need to do first is just consider that, put the box around it, what the angle that goes in that box, that's what we need to figure out, okay? And of course, we go about getting our 2 main angles first, as always, okay? So the first thing we're going to do is, of course, cos inverse 1 over root 2, and I'm getting 45. So again, just keep that in the box. This is what we're interested in. We want the angles, okay? So 45 degrees. Now again, as always, do your unit circle. And let's consider 45 degrees is obviously here in the first quadrant. That makes sense because we have a positive result here. The other place cos is going to be positive is, of course, in the 4th quadrant, in the C. So again, analysing our spacing, if that's 45 degrees up, that's 45 degrees down. So the other solution is, of course, 360 take away 45, which is 315 degrees. Okay, so now, what I'm going to do now is write it in its general solution form, okay? Again, as I said, with the triple angle, I will get rid of that 3 by dividing by 3, but not until the very, very, very end. So first of all, what I want to write is something that would express how to find all solutions. So what I do is I write 45 degrees, so this is my 3 theta, remember? And then I write that you will add on rotations of 360 degrees. So I'm going to write this as 360 degrees times n, okay? Where you can sub n, different values for n. For the first answer, you'll sub in n equals 0, and obviously get 45 degrees. There's your first result. If I want another answer then, I'll take another value where n is an element of the integers, so we'll take 1, so sub in 1. So that would give 45 degrees plus 360 degrees, so your first rotation, or your next result, if you like. If I want another solution then, I would do n is equal to 2, sub it in, so then I'd do 45 degrees, I'd add on 360 degrees twice to get another solution, and so on, n equals 3, n equals 4, n equals 5, and writing it like that, you see, gives us an expression for how to find all solutions. In other words, you just sub in values for n, and you'll just keep getting more solutions and more solutions and more solutions. So obviously we have this for our two main solutions. This is what you have to write out for yourself. 315 plus 360n, where n is an element of the integers. So there we go. So now we have it in its general solution form, and our final step is to now find theta. So if I want to find theta on its own, I've considered all my angles, but they of course are 3 theta angles. So now to consider theta on its own, I'm just going to divide everything by 3. So that'll be divided by 3, that'll be divided by 3, that's divided by 3, that's divided by 3, and that's divided by 3. So 3 theta divided by 3 is theta, 45 divided by 3 of course is 15, 360n divided by 3 is 120n, and then of course we have r theta is equal to 315 divided by 3 is 105, and 360n divided by 3 is 120n. So there we go. There is our final answers. Okay, we have the general solution and for the theta. And then just a final little note, if we were asked for it in terms of radians, of course you're going to multiply by pi over 180. So we would get the following. Pi over 12 plus 2/3 pi n, or sometimes it's written as 2/3 n pi. Sometimes they put the n in the middle, but either way it doesn't matter. They're both correct. Or converting this, again we're going to multiply all the angles there by pi over 180. And 105 works out to be 7 pi over 12 plus 2/3 pi n is 120n converted into radians, or 2/3 n pi. So there are your answers in degrees or in radians.